Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, determine the domain of g of x equals log of x squared minus 3x minus 4 plus 7. Write the answer in interval notation. All right, so they're asking us for the domain of a function that contains a log. Let's take a look at the steps. So step number one, we're given a log function. We're going to set the argument, which is x, greater than 0. And then step number two, we're going to solve for x, and that is our domain. So in this function here, this log function, who is the argument? Well, the argument is whatever you're taking the log of. So in this case, the argument is x squared minus 3x minus 4. So I'll go ahead and underline that here. This here is our argument. So we're going to set that to greater than 0 and solve for x. Now in this case, we have a quadratic. So we can't just solve for x normally. So what we're going to do is try to factor this, and then we're going to have to do a number line to see which intervals satisfy this inequality. So let's first start by factoring. So we're going to try to factor here. There's no common factors. Otherwise, we would try to take out a common factor out front. We're looking for factors of 4 that have a difference of 3. And I say have a difference because it's negative 4. So the two numbers must have different signs to multiply to a negative 4. So what two numbers have a difference of negative 4, multiply to negative 4, but have a difference of negative 3? The answers are 4 and 1. So it has to be 4 and 1. Now what about the signs? So for the signs, you want the inner term and the outer term to add up to negative 3. So you want the bigger one to be negative. So we want the 4 to be negative, which will give us negative 4x, and then positive here, 1x. So negative 4x plus 1x gives us negative 3x. All right, so we set each factor here equal to 0, and that'll give us our critical values. So let's go ahead and do that. So we have x minus 4 equals 0, and then x plus 1 equals 0. All right, so to solve for x here, we're going to add 4 to both sides. So we will get x equals 4, and here we'll subtract 1 to both sides, and we'll get x equals negative 1. All right, so those are our critical values for our function here. So now we're going to do a chart, and we're going to plug in values in each of the intervals. So let's set up our number line here. Now, really important, whenever you set up a number line to solve one of these inequalities, you only want to put the critical values on the number line. So it's tempting to add like 0, but you don't want to add 0 on the number line, just the critical values. So we're going to put negative 1 and 4 on our number line here. So negative 1 and 4. And then we're going to plug in a value in each of these intervals. So a really good number to plug in here is negative 2. Between these two numbers is 0. And then to the right of 4, we'll plug in 5. So let's go ahead and plug those in our chart here. So we have negative 2, 0, and 5. All right, so we're going to plug it into this quantity here. And really, we only care about the signs because we're just concerned if the product of these two numbers here is either positive or negative. So if I plug in negative 2, I'll get negative 6 times negative 1, which is a negative times a negative. So we have a negative times a negative, which gives us a positive. Next, we plug in 0. 0 minus 4 is negative. 0 plus 1 is positive. So we have a negative times a positive, which gives us a negative. Next, we have 5. 5 minus 4 is positive, times 5 plus 1, also positive. So we have a positive times a positive, which is positive. All right, so now we can put our signs on our number line here. I'll write them in red. So in this interval, it's always going to be positive. This one's negative, and then this one is positive. All right, so which of these intervals satisfies the inequality? Well, we want the product of these two factors to be greater than 0. What does greater than 0 mean? Greater than 0 means positive. So the intervals that are going to satisfy this inequality are this one and this one here. So I'll go ahead and put a check mark here and a check mark here. Those two intervals satisfy the inequality. All right, so we can go ahead and write our domain now. So our domain is going to be this first interval here, which is negative infinity all the way to negative 1. Now the question is, do we include negative 1? So let's go ahead and plug in negative 1 and find out. If I plug in negative 1, I will get negative 1 plus 1. So this will be 0 times anything is 0. Is 0 greater than 0? No, it's not. Therefore, negative 1 does not satisfy the inequality, and we're going to put a parentheses around it. All right, next we're going to do 4 to infinity. So 4 to infinity. So this interval here is the second interval that satisfies the inequality because it's positive. And now we have to test 4. Do we include 4 or not? So we just plug in 4 back into our function here. 4 minus 4 is 0. 0 times anything is 0. Is 0 greater than 0? No, it's not. So therefore, 4 is not included. So again, we're going to put parentheses and not a bracket. So here is our domain. So we have two intervals, negative infinity to negative 1, union with 4 to infinity. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.